Hi, in this playlist we're going to be looking at the Specimen Papers Set 1, and that's from the Edexcel higher tier. If you follow the link below in the description, you'll be able to download a copy of the paper yourself. Please do have a go at each of the questions. The whole idea is I'm going to make this video about 20 to 30 minutes long. Over the whole paper, that'll be maybe 3 or 4 videos. Please do work through each of the questions and then compare your solutions. Okay, so let's move on then with question number 1, which deals with a right angle triangle. And it says all the angles are in degrees and you've got to work out the size of the smallest. Now, it's not always a given that actually this is the smallest, even though it looks it, but I think in this particular case the main thing is we need to work out the value of x first and then decide the value of each of the angles. Okay, well, as you know, the angles inside a triangle add up to 180 degrees, so I can write 7x plus 5x plus 18, and don't forget that a right angle triangle here is 90 degrees, that's plus 90 degrees. If I add all of that up together, that's going to equal 180. Okay, so it's then just a case really of simplifying this and getting the value of x. So I've got 7x plus 5x, well that's going to be 12x. And then I've got 18 plus 90, well that's going to be 108. And that equals 180. If I then take 108 from both sides, I'm going to get that 12x equals 72, and if I divide through then by 12, I can say that x equals 6. Okay, so hopefully that's all right with you. Fairly straightforward in terms of a linear equation, but what it means is that if the value of x is 6, then 7 times 6 means that this angle is 42, and then I've got 5 times 6, which is 30, plus 18, well that means that this angle is 48. So actually, as they've drawn it, the size of the smallest angle is going to be 42 degrees. Okay, hope that's all right for you. Let's move on then to question number 2, which I must admit, when I first looked at this question, I thought there must be a catch to it, because it is actually a 3-mark question, because they give you the formula and they give you 2 values and then they want you to work out the third value. Okay, so we've got pressure equals force divided by area. Well, they've told you that the force is 140 newtons, and they've told you that the area is 35 newtons per metre squared. I beg your pardon, that the pressure is 35 newtons per metre squared. Okay, so I can just put that straight into the formula. So the pressure is going to be 35, and that equals the force divided by the area. Okay, so if I then want to find the value of A, I've basically got to rearrange this formula. The way I'm going to do that is I'm going to multiply both sides by A, because if I multiply both sides by A, it means I lose those 2 and I get 35A equals 140. If I then divide through by 35, I get A equals 140 over 35. And if I just work that out, it means then that I can divide top and bottom actually by 35 if you like, or I can divide it through by 5, or if I know that 4 lots of 35 actually make 140, then it means then this would be 4 meters squared, and actually that's the answer to this particular question. So providing you can manipulate this kind of formula then and work out the value of A, then it's then just a case of mental arithmetic to get that 4 meters squared. Okay, hope that's okay for you. Let's move on then to question number 3, and question number 3 deals with probability. Very, very common on these sorts of questions. It's a relatively straightforward question. where we've got the value of blue and the value of green here, and they want you to work out the values of those probability. And what they're saying is that they're exactly the same. Okay, so let's have a look at that. Probability of picking a blue counter is the same as the probability of picking a green counter. Well, all probabilities will add up to 1. So at the moment, I've got red is 0.24 and I've got yellow is 0.32. If I add those together, I'm going to get 0.56. And then if I take that away from 1 minus 0.56, well, that's going to give me 0.44. Okay, well, if both of these probabilities are equal, then it means each of those will be 0.22 and 0.22. Okay, hope that's all right for you, fairly straightforward. Let's move on then to question number 4. Okay, question number 4, actually, you can do it, I think, one of two ways. You could probably do it by trial and error, but the more kind of sophisticated maths way of doing it is to use a simultaneous, two simultaneous equations. So what we've got here is we've got a table, okay? Now, at the moment, what we're saying is the table has got a length of y and a width of x. Okay, well, if it's got a length of y and a width of x, it means then that this 11 is made up with 2 lots of y and 1 lot of x. And this 7 along here is made up of 1 lot of y and 1 lot of x. So actually we can put that into two equations where we're saying 11 equals 2y plus x, and we're saying that 7 equals y plus x. Okay, and then really it's just a case of working that through as a simultaneous equation. So what I can do is I can actually just minus one from the other. So I've got x minus x here. Well, that's brilliant because it then just leaves me with the y terms and some numbers. Okay, so I've got 2y minus y, well, that's going to give me y. And then I've got 11 minus 7, well, that's going to give me 4. So now I've worked out that y equals 4. And then it's just a case of putting that value of 4 back into one of these equations. I'll choose the bottom one because it's fairly straightforward. So I've got 7 equals y plus x. Well, I know that the value of y now is 4. So therefore I can work out that x equals 3, and actually those are my two values for each of the tables. So therefore, if I want to work out the total area, well, it's going to be y is 4 and x is 3. So 4 times 3 is going to be 12. So each of these tables is 12 centimetres square. Actually, they're not tables, they're tiles, or they're very, very small tables, but 12 on each of them, so 12 centimetres square on each of them. If I add all of that up, it means my total area of the tiles is going to be 48 centimetres squared. Okay, hope that's all right for you. Let's then move on to question number 5. And on question number 5, we've got a volume question. These do crop up an awful lot on these sorts of papers, so it's well worthwhile getting to grips with working out volumes. And what she's saying is that you've got this this sand pit, and we're going to fill it with sand. Now, importantly, we've got this 8 litres of sand in each bag. So what we need to appreciate from the very beginning is that 1 litre equals 1,000 centimetres cubed. Now, you do need that bit of information to be able to answer these sorts of questions, okay? So let's firstly work out the volume of the box. Well, the volume of the box equals area times depth, okay? Well, the area is going to be 40 times 100, and the depth is going to be 60. Okay, now if I calculate all of that, I've got 40 times 100 is 400, and 400 times 60 is going to actually give me 240,000. Now the way I've done that is I could actually do 4 times 1 is 4, and then 4 times 6 is 24, and then I've got 1, 2, 3, 4 zeros after that. Okay, so that's a really good way of using decimals. Now remember that this is centimetres cubed. Okay, and as we said before, 1 litre equals 1,000 centimetres cubed. So I could say that that's the equivalent to 240 litres. Okay, and then what we're saying is that a bag of sand covers 8 litres. So basically we need to know how many bags of sand. So sand, or bags of sand, is going to equal 240 divided by 8, which is going to give us 30 bags of sand. And therefore, if each bag costs £2.50, then the total cost is going to be 30 times £2.50. Okay, now I do this slightly differently. I'm sure that there will be ways of calculating this. Remember, this is a non-calculator paper, and I don't want to get too tied up in calculation methods. What I would generally do is I would do 30 times 250, and then I would move the decimal point back. But I'm aware that there are other ways of doing these sorts of calculations. Either way, you should end up with £75. Okay, so therefore in this particular case the sand isn't going to cost less than 70 quid, it's just going to cost 75. So Sally is incorrect. Okay, I hope that's all right for you. Let's move on then to question number 6. Now question number 6 deals again with probability. Probability seems to be cropping up a fair amount in some of these papers. So we've got 4 friends, each throw a biased coin a number of times. Okay, the coin is going to be thrown 1 more time. Which of the 4 friends' results will give you the best estimate? Okay, well, you've only got 1 mark in this, but basically what we're saying is that Ben's throws, he lands on heads 34 out of 42 times, because he actually makes 42 throws altogether. Okay, Helen, she makes 78 throws altogether, and she lands on 60. She lands on the head 66 out of 78. But if you kind of work through this, what you will be able to see is that Sheriff, there's this guy at the end here, he actually throws 160 times and it lands on heads 120 times. Okay, so therefore Sheriff has the best estimate, okay, because it's the greatest number of throws. Okay, and generally speaking, with these sorts of questions, if they ask you something like this, that's really what they mean is that the accuracy is going to improve, or the accuracy of the estimate is going to improve, because he's just thrown it a greater number of times. Okay, however, the next bit of it is a little bit more interesting, I think, as Paul says, with this coin you're twice as likely to get heads as to get tails. Is Paul correct? Well, if we look at Paul, actually in Paul's experience he is correct, because in Paul's case, okay, we're looking at 80 out of 120. So 80 out of 120, and we can reduce that down to 2 heads out of 3 throws, total number of throws. So in his particular case, he's absolutely right. However, he's not correct if we take into account all of the throws, and this is the important thing here, because actually if we add up all of the results, what we've got is 300 heads and 100 tails. Okay, so what that means is that if we take all the throws, if I put however, all throws is going to be 300 out of 400. So there's 300 heads out of 400 throws in total. Okay, so if we take that into account, then Paul is incorrect. Okay, it's only in Paul's experience that it's correct, but actually not overall. Okay, So hopefully that's okay. And then it says, final question, it says the coin is to be thrown twice. Okay. Use the results and interesting again, it says all the results in the table to work out an estimate for the probability. Okay, well, the estimate is going to be this, which boils down to 3 out of 4. Okay, so it's going to be done twice, so we're going to multiply those two together, and that's going to give us 9 out of 16. Okay, hope that's all right for you. Let's move on then to question number 7. Now, I'm very aware of the time on this particular video, and we're in at the moment to be about 15 minutes, so I'm going to aim to keep this to about 20 minutes to 30 minutes if possible. Okay. Now, the first one is, sometimes these questions do get hidden away a little bit. So the first one at the very top there says, write down the exact value of cosine 30. All right, there's a couple of different ways of doing this, but basically it boils down to really, you need to remember it. Okay, you need to know that cosine 30 is root 3 over 2. Okay, you just need to know that, and it is only 1 mark, so you can spend a fair bit of time on these sorts of questions sort of proving it, but ultimately if you've got some way of remembering that, it's going to be much easier for you. Okay, so given that sine 30 equals 0.5, work out the value of x. All right, well, sine of anything is equal to the opposite over the hypotenuse. Okay, so what we're saying is the sine of 30 is going to be 0.5, and we're going to try and work out x, which is the opposite, and the hypotenuse is 12. So the opposite is there, and the hypotenuse is 12. Okay, well, if we want to work out that, we're just going to cross multiply, or we multiply through by 12. So that's going to mean that the opposite is going to be 6 centimeters, and actually that's the answer to this particular question. Okay, 17 minutes into the video, let's move on then to question number 8, which actually cropped up in a fairly similar form in one of the earlier papers that we did, and that is working out, importantly this word, an estimate for the mass of Saturn. Okay, an estimate. All right, well, remember that an estimate is just code for one significant figure. Okay, so really we're looking at that meaning 1 sig fig. Okay, so we've got this 1.899 times 10 to the 27, and we've got to work out the mass of Saturn, knowing that it's 0.3 times the mass of Jupiter. Well, in that case, to one significant figure, what I'm going to say is that is going to be 2. Okay, so 2 times 10 to the 27. Okay, and that's going to be multiplied by 0.3. Okay, so let's have a look at that. Well, 2 times 10 to the minus 27 times 10 to the 27 times 0.3. What I normally do is I bring the two multiplications together and then leave the standard form afterwards. So I've got 2 times 0.3 times 10 to the 27. Okay, so 2 times 0.3 is going to be 0.6 times 10 to the 27. Okay, now that would give you probably 2 marks out of the 3, because strictly speaking it's not in standard form. You need to make sure this first number is between 1 and 9. So actually the answer to the question will be 6 times 10 to the 26, because I've got to move my decimal point back again. Okay, and then it says, give evidence to show whether your answer to A is an underestimate or an overestimate. Well, actually, it's an overestimate. Okay, and the reason it's an overestimate is because I've rounded up. Okay. Now, if you want to, again, if you've got time, you could sort of plug in a few figures just to see if that works out for you, but it is only a 1 marker. Okay, so don't spend too much time on those sorts of things. You're far better spending a bit more time on question number 9, which is 3 marks. Now, this particular one could be a little bit confusing, I guess, but it's kind of worthwhile working through, because really you need to be aware for this sort of question that the mean is equal to the total amount of points divided by the total games. Okay, so let's look at 11 games, which is the first one, and it tells you at the end of 11 games their mean score is 33 points per game. So the mean score is 33. Okay, their total points we don't know, but we're going to work it out. But they've played 11 games, so actually if we then just cross multiply through by 11, it tells us that their total points in the 11th game, in the 11 games that they've played, is going to be 363. And then really we just duplicate that for the 10 games that they've played, because it also gives us information on the 10 games. Okay, and what it tells us is that their mean score was 2 points higher. So in this particular case, their mean score is now 35. We don't know their total points, but we do know that they played 10 games. Okay, so with 10 games, if I just put a line down there, with 10 games, it's going to be 350 equals their total points. Okay, so Warped Reds must have scored 13 points in their 11th game. Well, yes, they did, because the difference between their 10th game is 350 points and their 11th game is 363 points. So therefore, that is true, okay, or it's correct. 13 points in the 11th game. Okay, hope that's all right for you. Let's move on then to question number 10. Question number 10, we've got, again, a bit of probability, but this time it's all about red counters and yellow counters. One of these fairly standard questions that you kind of come across. However, just looking at it, initially on the surface did look like probability, but actually it's probably better explained as a ratio, because what we're saying is the ratio of the number of red counters and the number of yellow counters is 1 to 6. So let's just kind of work that out first, or at least write that down as a mathematical statement. So red to yellow is going to be 1 to 6. Okay, now what it says is that there are 30 yellow counters in the bag. Okay, so on this initial point there's 6 yellow counters. Actually there's not now, there's 30 yellow counters, which is 5 times bigger. So if it's 5 times bigger the amount of yellow counters, then it must be 5 times bigger the amount of red counters, so that's going to be 5. So if we want to work out the number of red counters in the bag, there's actually 5 red counters. Okay, hope that's all right for you. We can kind of use a similar sort of idea now with part B, and what we're told is Riza put some more red counters in the bag. The ratio of red counters, the number of counters is now 1 to 2. Okay, so let's just write that down. We've got red to yellow, and we've got 1 to 2. Okay, what we're actually saying is that the yellow counter in the bag hasn't changed. You've still got 30 of them, which is actually now 15 times bigger. Okay, because 2 times 15 is 30, so therefore it makes sense to then multiply this by 15 times bigger, so they must be 15 counters now in the bag. Now don't forget, originally there were 5, there's now 15, so 15 take away 5 is going to be equal to 10, so she must have put 10 red into the bag. Okay, hope that's all right. Let's just finish this video with question number 11. This is a 1 mark one. Bit mean really for 1 mark. You've got to do a little bit of work on this, but you've got to kind of remember that if it's 125 to 2/3, that's exactly the same as saying 125 to the third squared. Okay, well 125 to the third is same as saying the cube root of 125, okay, squared. All right, well the cube root of 125 is going to be 5, okay, because 5 times 5 times 5 is 125, and then we got 5 squared, So that means that the answer to the question will be 25. Okay, so that's 24 minutes into the video. I hope that's been all right for you. I'm going to stop here at the end of question 11, and then we'll start again in the next video in the playlist on question number 12. I hope it's been useful for you. Please do add a comment below if you're not sure about anything. Subscribe to the site. Have a look at some of the other videos in the channel. Hope they're useful, and I'll look forward to seeing you inside the next video.